So tonight the program is going to focus on Apollo 8. It's been almost 50 years. It'll celebrate the 50th anniversary in December. And while Apollo 11 is usually remembered because it left footprints on the moon, Apollo 8 really blazed the trail and made it possible to meet Kennedy's goal of landing on the moon and returning back to Earth by the end of the decade, which would have been the 60s. To fully appreciate what was going on in 1968, you really have to revisit the world as it was in the late 50s and 60s. For those who didn't grow up during that period of time, it was referred to as the Cold War. While there were some proxy wars being fought, it really was a war of ideology between the Soviet Union and the United States. And the Soviet Union was very active in expanding its influence, in some cases militarily. Not only were they battling on the land, but the battle started to move into the sky. And as the military referred to it, it was the battle for the high ground. If you could control the area around the Earth, you had a distinct advantage, particularly in the era of ballistic missiles and nuclear weapons. The Soviets struck first when they orbited the first artificial satellite, Sputnik, in 1957. And while this was a small satellite and it didn't do much except transmit a radio signal, the fact that the American public could go outside at night and see it pass overhead creates a lot of apprehension, because if the Soviets could launch even a small object, what else could they put up there? This was back in the days when school children were being taught to hide underneath their desks, duck and cover. So it really escalated the tension of the time. You also have to remember that at this time the Soviet Union was a closed society. We didn't know anything about what was going on behind that Iron Curtain unless they announced it. So, as you would expect, they only broadcast positive events and propaganda, and we really didn't have a lot of details. So a lot of the information that I based my talk on tonight only became apparent after the fall of the Soviet Union, and we started to get historical recounts of what was actually going on during that time period. So the Soviets followed up the first couple of launches with a series of firsts. Of course, you're all familiar with they were able to launch the first cosmonaut to orbit the Earth, Yuri Gagarin, but they also had a number of other firsts, sending objects out beyond the Earth's gravity, sending objects around the moon, the first to send 2 people into orbit, and the first actually to send 3 cosmonauts into orbit. Now, while these were publicized as firsts and great accomplishments, of course they didn't report on maybe some of the details that would have been inconvenient at the time. For example, when they launched 3 cosmonauts into orbit, they launched them in a 2-person spacecraft. And because there wasn't any room, they removed the ejection seats, and the cosmonauts weren't able to wear spacesuits. Facts that were kind of left out of the reports. The reports just basically proclaimed that they had accomplished a 3-person flight. Something that you probably wouldn't have seen in the United States, given our predilection to safety. So, as you are probably aware of, we did respond with our first satellite, Explorer 1, And unlike Sputnik, it actually carried some instruments and discovered the radiation belts around the Earth, which are named after the gentleman that designed the instruments, Van Allen. Congress also passed the National Defense Education Act, started to infuse money into the universities, into the schools, to raise the level of education at all levels so that we could compete with the Soviets. And of course, Congress also passed the act that created NASA 60 years ago. NASA just celebrated their anniversary at the beginning of October. And President Kennedy took a bold step and called for the United States to land on the moon by the end of the decade. When he made this proclamation, we had approximately 15 minutes of experience in spaceflight, having only launched a suborbital flight with Alan Shepard. So he took a gamble that we could assemble the resources of this country and put them to use on a goal to launch and recover people to the nearest object in space. It got off to a rocky start, and if you were one of the early astronauts witnessing some of these launches at Cape Canaveral, I'm sure you were a bit apprehensive when you saw rockets that only moved 6 inches off the pad before falling back and exploding. But marshaling the talents that we had, we were able to develop 2 programs, the Mercury program and the Gemini program, as stepping stones, incrementally gaining experience so that they would pave the way to the moon. So we had 6 Mercury missions, which were a single occupant, and 10 Gemini missions that carried 2 astronauts each. And over that time period, we gained all the skill sets needed to advance to the Apollo program. Now, the real challenge in getting to the moon, we had experience getting to low Earth orbit. The Russians had experience. We both had several vehicles that could put payload and men in orbit. But getting to the moon would take quite a bit more than the rockets that we had available. And it really came down to who could develop a heavy booster before the other one. And there were 2 personalities that really were the front of the program. On the Russian side, the Soviet side, we had Sergei Korolev. And then on the American side, we had Wernher von Braun. And these 2 visionaries were instrumental in developing the moon rockets for each country. Now, we never really sure, as I mentioned, what the Soviets were doing. Our spy satellites didn't provide continuous coverage. They were fairly antiquated compared to what we have today. It was still in the days where the spy satellites were using film. And once they took the images, they would eject the film canisters and they would be recovered back on Earth. And we would take the film canisters, develop pictures. So there's a lag time between when the intelligence was captured and when we actually were able to process the intelligence. So we did know the Soviets were working on something. We did pass over their launch pad and actually captured their moon rocket on the pad. We didn't know anything about it. We didn't know if it was operational. It was actually turned out to be a mock-up they were using to integrate the launch pad facilities. But it was certainly on the same scale as the Saturn V. They were also working on a lunar lander, which you can see on the left. It, again, didn't have the same level of sophistication as ours did. In fact, the cosmonauts had to actually climb out of the lander to get to the docking spacecraft. So there was no internal tunnel like there was in the Apollo program. So if you had to get out of their spacecraft and get into the lunar lander, you had to do it with a spacewalk. And you can see there's an assembly picture on the right of their moon rocket called the N1. And you might notice that it actually has 30 engines in the first stage. So it was quite a bit of complexity that all had to work together. So while they were working on their moon rocket, of course, we were developing the Saturn V, which to date is still the most powerful rocket ever built. And you can see way over on the right there, they're testing one of the Saturn V engines, the F1 engines. Just to give you a sense of scale, that engine, if you can see it down there, being test fired, the nozzle is 12.5 feet in diameter. So these were huge engines. That instrument ring up there on the right was 22 feet in diameter, and that was installed on the top of the third stage. The first stage was actually 33 feet in diameter. So you're talking about a massive rocket. All told, the rocket was 363 feet. So the next time you're walking by that football field out back, if you laid that rocket down, it'd be longer than the football field. So you can see they brought the rocket in by stages and assembled them at the Space Center. There's the first stage being brought in on the left for Apollo 8. And the lunar lander was still being assembled and going through its testing phase up in Long Island at the Grumman facility. So both programs, the Soviet program and the American program, are moving along. In 1967, they both were set back by disasters that involved fatalities. 3 American astronauts died on the launch pad during the testing of Apollo 1, and the Russians were testing a new deep space craft called Soyuz 1, and on re-entry the parachute got tangled and the spacecraft crashed. So both incidents set back the programs, and both countries responded in a different manner as far as recovering from those events. But in 1968, we had less than 2 years to complete Kennedy's goal. NASA was still testing hardware, but it hadn't flown anybody on that hardware since the Apollo fire. The command module, after the fire, had been completely redesigned. They had pulled out any flammable materials, they had rewired the craft, they had redesigned the hatch that the Apollo 1 astronauts couldn't open easily. So the whole spacecraft was been redesigned but hadn't flown yet. NASA was taking a very cautious approach to getting back on track. They were going to fly 3 low Earth missions, Apollo 7, Apollo 8, and Apollo 9, all around the Earth just to test out the equipment before they even thought about going to the moon. But the lunar lander was considerably behind schedule. It turned out to be a lot more difficult to build than Grumman, I think, had anticipated. And the budgetary pressures were increasing in '68. If you look at your history books and go back to 1968, you find that that was a year in turmoil. You had cities burning from race riots. You had anti-war demonstrations. You had 2 political assassinations between Martin Luther King and Robert Kennedy. Just in 1 week in Vietnam during the Tet Offensive, we lost 543 servicemen. So it was a tough year, and Congress was looking to reallocate funds to different purposes than going to the moon. The Soviets had also raised the stakes. They were launching, as I mentioned, a number of spacecraft. Most of them they declared were successful. We had limited intelligence. We did have, in one case, when they launched Zond 5 that actually circled the moon and returned, we did have a destroyer out in the Pacific Ocean shadowing the Soviet recovery ship, so we were able to photograph the re-entry of Zond 5. But other than that, we didn't have a lot of intelligence on what was going on, but the word around the intelligence agencies was the Soviets were going to try something in December. They were going to try to launch people around the moon. In August of '68, George Low, who was the manager of the Apollo Spacecraft Program Office, came up with an idea that why not just send Apollo 8 to the moon. Apollo 8 had been originally just a low Earth mission. It was supposed to be testing out the lunar module. The lunar module was way behind schedule. It wouldn't be ready. So there really wasn't a good mission for Apollo 8. And it might have to be deferred until 1969 before all the equipment was ready. So he came up with a concept to let's send Apollo 8 around the moon. We'd be able to get a lot of experience on deep space navigation. We'd be able to get a first-hand look at some of the landing sites that we'd be targeting. There was a lot of advantages to doing something like this, and we'd be able to check out the equipment. He bumped that idea up the management chain. It met with some skepticism at first, but slowly a lot of the different parts of NASA started to buy into the program. Senior management flew down to Huntsville, talked to Werner von Braun, asked him whether he could have the Saturn V ready. It was having some issues as far as flight worthiness. He assured them that he could take care of that. They talked to the folks at MIT. Could you get the programming for deep space navigation done? Talked to the astronaut office. So there was a number of challenges, and slowly everyone came together with a consensus that it was possible. So that idea was presented to James Webb. At that time he was the administrator of NASA, and a compelling case was made, and they decided that it would be a go, but let's launch Apollo 7 first. If it checks out, we'll make a public announcement. So they held off until Apollo 7 flew. It was a risky venture. And I already talked about some of these challenges, but again, we had a lot of experience in orbiting the Earth. We had never ventured beyond that point. And if you think for a second, if you go out tonight and you look up in the sky and you see the moon, it appears relatively close, but as a sense of scale, if the moon was a tennis ball and the Earth was a basketball, you would have to place the tennis ball 24 feet away from the basketball. So it was quite a leap from just orbiting the Earth to actually traveling to the moon. The moon is also a moving target. So if the moon is, if the moon is, can't get the pointer to work, but if the moon is down here at launch, you have to lead the moon. You have to lead with the spacecraft so that you meet at a point in space. At the launch of Apollo 8, the moon was 218,000 miles away. It was moving 38 miles every minute in its orbit. So if you want to arrive at a point in space approximately 70 miles ahead of the moon in 3 days, you have a margin of error about 2 minutes. If you arrive too early, you could miss the moon altogether and hopefully swing around back to the Earth. If you arrive too late, well, there could be consequences. When they were looking at a decision to launch, they had to look at factors like where the Earth was going to be in its rotation, so that when the Apollo 8 spacecraft was behind the Earth and fired its third stage engines, it would rendezvous at a point where the moon would be. They also had to consider that as the Earth rotates, you want to make sure that when you come back from the moon, that the site that you're going to be recovered in the ocean is right underneath you. And, as I mentioned before, you want to make sure that the proper area of the moon is illuminated so that you can photograph and survey the areas where future missions would land. So taking into all these factors, a date in late December was picked. The one concern NASA had about picking that late date was that all those factors for the Soviets came together in early December. So if they were thinking of going to the moon, their launch window opened up at least 2 weeks earlier than our launch window. The crew that flew Apollo 8, Frank Borman, Jim Lovell, and Bill Anders, were originally assigned to Apollo 9. The Apollo 9 crew, they were given the option of flying to the moon, and they decided they would opt out of that and instead do the original mission that they had as far as testing the lunar lander in near Earth orbit. So Borman was offered the mission. He accepted, but he only had 16 weeks to retrain for what he originally had been assigned to do. As I mentioned, it was a risky mission. Frank Borman's wife, Susan Borman, after she heard her husband was going on this mission, she went to the flight director, Chris Kraft, and asked him honestly, tell me what the odds are for this mission to succeed. And Kraft said, about 50-50. So while they had confidence that they could pull it off, it wasn't a slam dunk by any means. You had to prepare all the navigation. Now we were going beyond Earth orbit. And back then, if you were around at that time, computers were usually the size of a room. So getting a computer down to something that you can put into a spacecraft and have all that computing power necessary to guide you to the moon and back was quite the challenge, and most of that was done up at MIT's instrumentation lab. And they also did a lot of the software. At the time this computer was being built, integrated circuits were just coming into to being. In fact, NASA was consuming about 1/4 of the world's supply of integrated circuits at that time. There weren't that many being made. They also used something on the right there called rope memory, where they actually hardwired the program into the computer. And the hardwiring was done by a team of women, and the method was called LOL, little old ladies who were actually wiring the memory. You see the next picture, a woman wiring, whoops. So the memory was wired around these cores, iron cores. So you can see, even though that computer was very primitive by today's standards, they were able to program 44 programs into that computer, hardwire 44 programs, and they used up an equivalent of 64 kilobytes. So very efficient programming. You probably recognize the picture on the right. That's Margaret Hamilton. She was in charge of writing the code. She was the lead software engineer for the guidance and navigation systems. But once she was done writing the code, she would ship it off to Raytheon, where they were wiring up the hardwire programs. And the reason they did that, one of the reasons is that they were concerned about radiation in deep space, and radiation affecting computer memory, and cosmic rays knocking out silicon chips and causing errors. So they wanted this thing as foolproof and as error-proof as they could possibly get it. As I mentioned, the command module will be completely redesigned. It was hand-built, each one of these command modules, from 8,000 drawings, and each one contained up to 3 million parts. So even if you had a 99.99% reliability on parts, there were still a large number of parts that could fail when you have 3 million. Just to give you an idea of how complex the cockpit was, Frank Borman, the commander, would have been sitting in the left seat. Jim Lovell would have been in the center, and Bill Anders would have been in the right. So you can get an appreciation of why it took so long to train these astronauts. This is a very complex machine, and there were just an infinite number of ways things could go wrong, so they had to train on any eventuality. The last piece of the puzzle was the Saturn V. As I mentioned, it was 363 feet tall. It weighed 6.2 million pounds at launch. And the thing that really kind of brings it home to me is that you're lifting 6.2 million pounds, 42 miles, in 2.5 minutes. I mean, to me, that's just mind-boggling. Lifting that kind of mass, 42 miles in altitude in that short a period of time. And you can see the fuel that it was consuming in that period of time. The second stage, once the first stage dropped off, would bring it close to orbit. Third stage would bring it into orbit. And then after 2 orbits, they use the third stage, relight the engine, and propel it out towards the moon. Saturn V had some growing pains. They had launched a test flight in April, an unmanned test flight, and they experienced a lot of vibrations. In fact, the vibrations were so bad that it was exceeding the design criteria. And what was happening is that as the fuel was being consumed, all that empty space in the tank was allowing the fuel to slosh around, and it was creating a pogo effect. And the pogo effect was inducing vibrations in the actual structure of the rocket. But and also they lost 2 engines on the second stage because of cross wiring. But Von Braun was working on that, and his team was confident by December they would have a vehicle that was ready to go. As I mentioned before, Apollo 7 was launched 50 years ago. The flight was almost perfect, and because of that, James Webb decided that they would go to the moon in December. So, after all that, the Apollo 8 mission was launched at the end of December, December 21st. It was the first time that humans had left the gravity field of Earth. They achieved lunar orbit on Christmas Eve, going behind the moon, firing the service engines module to slow them down and be captured by the moon's gravity. They completed 10 orbits of the moon. They were the first humans to see the far side of the moon. And then they refired their engine Christmas Day to head home. So it was not quite that easy, and they had definitely a lot of issues arise during the travel. Space sickness. They had never really run into that because the Mercury and Gemini capsules were so small you really couldn't move. But Apollo was large enough you could float around, and that really disoriented the human body, the human ear. Frank Borman was very, very sick for the first 3 days. So sick that once the flight surgeon found out about it, there was even talk about turning it around, coming home. Jim Lovell caught his life vest after launch on a switch. The life vest deployed. You wouldn't think it's a big deal, you just deflate it. Unfortunately, the life vest was full of carbon dioxide, so he didn't want that in a closed space. And they eventually figured out a way to vent that outside the spacecraft. They had a number of other issues, none of them life-threatening or mission-threatening, but some of them were very uncomfortable. Of course, with Frank Borman being sick all that time and not being able to capture everything that comes along with space sickness, you had things floating around the capsule that made, I'm sure, the odor pretty bad inside. Never mind, you also had to capture all the human waste that you were generating in little baggies. And of course, those baggies sometimes are not 100% sealed. So I'm sure the capsule started to reek after a period of time in there. They had air conditioning in there, but they had no heat. So at times when the capsule wasn't in the sun, it got pretty cold in there.
No, but they have heat, air conditioning. They got mixed up.
Yes, I do have it mixed up. Thank you. Yes. Well, the heat, I meant it was getting warm in there. Yeah, all right. I'll fix that. Thank you, Gavin. I'm glad I invited you tonight, Gavin. Oops, I'm all mixed up. Okay. And of course, there was the stress of the mission. Frank Borman had buried his good friend Ed White, who died in Apollo 1 and lived in his neighborhood. So I'm sure there's a lot of mission stress about getting this mission done and getting it done right. Some of the images that they took out the windows as they were circling the moon. That one up in the top left, that triangular shaped mountain, is informally, until just recently, named Mount Marilyn after Jim Lovell's wife. So the astronauts would name a lot of landmarks so that the next crew coming could use those landmarks to find their way to the landing site. So Mount Marilyn was on the way to the Sea of Tranquility. Of course, we saw images from the far side, down the left there, that we had not seen before. Vastly different than what the near side looked like. And then we got to appreciate the Earth from a distance. In fact, I think Bill Anders said it best, is that they came to study the moon, and what they really discovered was the Earth. So coming back, the command module and the service module separate about 10,000 miles out. Then about 15 minutes later, the command module enters the atmosphere and and lands in the Pacific Ocean under a parachute. It landed about 3 miles from the recovery ship, which is very good accuracy. Just wrapping it up, Apollo 8 was really a pivotal mission. I don't think if we hadn't done Apollo 8, we may not have been on track to land on the moon 7 months later. When you think about it, 7 months is not a long time. But Apollo 8 kind of set the standard. It checked out all the equipment. It proved that we could do it. It was made possible by a coordinated effort. If you look at the number of people and companies and universities all working together for a common goal, that's something you don't see very often. And it shows what the American people and the American spirit can accomplish. Russians didn't give up. I mean, they were still working on their moon rocket. Unfortunately, they were having a lot of technical and mechanical issues. They launched their moon rocket for the first time in February of '69. It was a fairly successful flight for a while, but unfortunately during launch they had broken a pipe inside the first stage that was spewing fuel, and eventually that fuel exploded and the tail of the rocket erupted in flames, and that was a total loss. The second mission of the moon rocket was only 3 weeks before Apollo 11, and they had a problem with launch. It actually didn't even get a minute into the mission before the vehicle exploded. They tried 2 more launches of the N-1 before they canceled their moon program. By that time, the Americans had walked on the moon several times. The Russians had moved all their resources into other areas they felt they could surpass the Americans: space stations, unmanned missions to the planets. But that was the end of their moon program. And really, Apollo 8 was a key mission and event in really beating the Russians and winning that race. You've probably seen these iconic images. It was the first time that we'd actually seen the Earth from a distance. Before that, orbiting the Earth, we'd just seen pieces of the Earth. Now we saw the whole blue marble. And of course, Earthrise, when the Apollo 8 astronauts saw the Earth rise over the limb of the moon. Just recently, the International Astronomical Union renamed 2 of those craters in the picture of Earthrise after Apollo 8 and Bill Anders as the photographer. They've also acknowledged officially now that triangular-shaped mountain is now called Mount Marilyn. So thank you very much.